Okay, welcome to another episode of H2 Math. Okay.
Welcome back.
Yes, welcome back with Kenny and Greg. So today we're going to discuss about convergence and divergence of a series. So converge basically just means something like that, when you go in this direction. This is a converging ray, right? Diverging ray, well, why does it feel like I'm teaching physics? You take physics?
Yeah, I think physics.
Yeah, so the diverging rays basically they go outwards. Converging rays go inwards and they go towards a point. Right? This is converging. Right? And this is diverging. Okay? Hello?
Yeah,
Hello?
sorry.
Yeah, okay. Okay. If S infinity, okay, so we come back to the notes here. Okay, convergence and divergence of a series. So if S infinity is a finite number, okay, S infinity, what is S infinity? S infinity means this is sum to infinity. Okay, what does sum to infinity means? It means, right, okay, in a sequence, let's say we have a whole sequence of numbers. Okay, let's say we have a whole sequence of numbers. Let's say we have like first term, we have like second term, we have like third term, so on and so forth, right? Okay, so what does it mean as sum to infinity? Sum to infinity means we're going to sum from the first term plus second term plus third term all the way to the end. All the way to the end. There's no end to this, you see? We're going to sum all the way to the end. Okay, so
Yeah.
when we sum everything, when we sum every single term in this sequence, okay, we call it the sum to infinity. And sum to infinity is usually part of a converging sequence. Not usually, it should always be part of a converging sequence, which means as you add these numbers up, right, it should converge towards a certain number. One good example would be 1, half, 1/4, 1/8, 1/16, 1/32, so on and so forth. So we can see a pattern here, which is times 12, times 2, times half, times half, okay, consecutively multiplying by half. We can see that the numbers get smaller and smaller and smaller. And the numbers get more and more trivial, more and more insignificant, right? They only contribute to the last few decimal places. Make sense?
Yeah.
Yeah, and as we go on, right, maybe after like 1,000 terms, 2,000 terms, the numbers do not play such a significant role in changing the actual number itself. It becomes insignificant. You can no longer even see it on the calculator itself. You don't really see a difference, That's why this whole chunk here is called a converging sequence, because eventually, no matter how you add, right, it's going to stop at a particular number. It's going to converge towards a number.
Which is going to be 0, is it?
No. Of course not 0 lah. You see,
but it becomes very small. Oh.
You have 1 plus half plus so on and so forth. How can it be 0? You already have 1 here. You keep adding, confirm it's going to be more than 1, right?
Oh.
Yeah, it cannot be 0. The first term is already 1, dude.
I thought it becomes smaller and smaller.
No, the terms in the sequence become smaller and smaller. But when you add, right, it should become bigger and bigger. But how big will it get? It will only get big to a particular number. It will not get any significantly bigger. Understand? Yeah. Okay, the best way to explain this is using a square. Okay, you'll be like, huh? What are you talking about? Let's draw a square. Okay. So this is half of a square, right? Hello?
Yeah, sorry.
Yeah, this is half of a square, okay? So let's say I already have half a square. I'm going to add 1/4, okay? So this is 1/4, right? Right, this is half. This is 1/4, okay? Then after that, I'm going to add 1/8. Then I'm going to add 1/16. Then I'm going to add 1/32. Then I'm going to add 1/64. Can you see where I'm heading to? I use half plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus 1/62. I can keep dividing the squares up, you know. And at the end of the day, right, when I add all this, when I add to the infinite number of terms, I add to the 9 million term, you know, it's going to converge towards a number. And the number here in this specific scenario is going to be 1. Can you see it?
Oh,
Yeah. Yeah. So,
Oh,
but
okay.
it really depends on what the first term is. Because now our first term is half. Half plus 1/4. Okay. But let's say for this sequence that we have originally listed out, we have 1 plus 1/2 plus 1/4 plus 1/8 plus 1. This one will converge to give us what? When we add all the terms together.
It's gonna be 1 or so.
It's going to be 2, right?
Oh, 2, yeah, plus, yeah, 2.
Because we have to plus this 1 here.
Yeah.
Makes sense? So the best example is to use the square to explain, because from here you can clearly see that no matter what, I keep halving it, I keep adding the half of something, half of the remaining portions, half of the remaining area. No matter what, it's still going to fit into that square. And it's how many squares is that? It's only 1 square. Right?
Yeah.
Yeah, that's why it will converge. It will fit in that square. 可以吗?
Yeah, I
Yeah.
understand.
Yeah, understand now. So, okay. Hold on. I'm going to tell you something that's going to blow your mind. Are you ready to be mind blown?
I should prepare that cheering. Wait, hold on.
Okay, sure. You are very you are very good co-host, you know. Yeah, you're a very good co-host. Your sister, right, is seriously not cooperative at all. Yeah.
Really?
Yeah, I tell her that she's what?
I thought she was more cooperative.
No, she's so sian, you know, during the whole lesson, she's like,
So
she's just so sian. Then after she didn't know it was recorded. She didn't know it's recorded. Then after I told her that this is recorded and it's going to go onto YouTube. Then she was like super reluctant. She kept asking me to stop recording.
At first I was also kind of like that. But now I'm more used to it.
Yeah, but it's fine lah, right?
Yeah.
Yeah. Because I think, okay, firstly, the reason why I want to upload to YouTube is because firstly it's for you all to review, like, because you may be asking me about this sum to infinity thing, then after that maybe 1 week later you forgot, right?
Yeah.
So this is where you can play back the video to understand, oh yeah, I remember already, Kenny went through this with me.
Oh yeah.
Yeah, it will really be a lot more convenient instead of you coming to ask me. Then, you know, I'd rather you ask me about like newer stuff than to ask me about past stuff. You understand what I mean?
Yeah.
Yeah. So that was my top priority lah. It's not, I didn't upload to like gain popularity. I mean, yes lah, there's
So
one thing to
YouTube can
also,
pay.
yeah. No lah, it's not really lah. That's not the primary objective.
Yeah.
But of course, I also want to get the word out lah that, you know, I'm tutoring math here. Yeah. Okay, so I'm going to say something that's going to blow your mind, man. So just now we realized that these sequence are 1/2, 1/4, 1/8, so on and so forth. You know, it will approximate to give you 2, right? The sum to infinity, right? This is the sum to infinity, right?
Yeah.
Makes sense. So there is a formula created there is a formula created for sum to infinity. Do you know that? There's a shortcut. There's a shortcut to know because it will not always be in this order one. It's not always like all 9 times half times half times half. It can be like times 1/3 or times 1/4. Then how are we going to know? You know, you get what I mean?
Yeah.
Yeah. So the formula is U1 over 1 minus R. Okay. What is U1? What do you think is
The
U1?
first term.
Very good. This is the first term. What is R?
Yeah, it's remainder.
No, it's called the common ratio. Or in this case, you can understand it as the common multiple, which is half in this case, right? Because you keep multiplying by half. So this half here is your R. Okay.
Yeah.
So if you were to substitute it, okay, we don't have to know all the terms. We don't have to really add up all the terms to like maybe the 10th term or 20th term, because some students will be like, oh, to find sum to infinity, maybe I just add up to the 20th term or 30th term, then that will suffice. I will can more or less know, oh, it tends towards this number, you know. Yeah. But no, that mathematically that is not sound. So we have to use equations. So U1 is 1, right? That's the first term.
Yeah.
Right. Then after that, 1 minus, what's the common ratio? Is half.
Half.
So you get 1 over 1 minus half is half.
Half.
What 1 divided by half is?
Just 2.
2. Nice.
Oh.
Mind blown.
Oh, wait, this wait, this is just for you to find the
Sum
final
to
number,
infinity.
is it?
Yes.
Oh, like this. Okay.
Yeah, because now you need to find the convergence of a series. Convergence of a series means to find the sum to infinity. Or if it's an infinite, if it's an infinite sequence, you have to find sum to infinity. If it's not an infinite sequence, means if it's a finite sequence, means there is an end to it, then there's another formula for that.
Okay.
Which I will go through with you. Okay?
Yeah.
Okay.
Yeah.
So remember this formula. You can write down somewhere on your notes.
Yeah, writing it down.
Fantastic. And remember to annotate the what is U1, what is R, in case you forget again.
Okay.
Hey, you know, right?
Yeah.
Right now they are very strict with the measures.
Yeah, because of
like
Zoom.
Yeah, because I mean I'm telling you this because I got a feeling that you might go out and maybe do some pull-ups or something like that. Like you know you cannot go to the fitness corner. Like, yeah. You go fitness corner or anything, right? They will straight away upfront give you $300 fine. I mean, yeah.
Wait, even my house downstairs you cannot go.
Your house downstairs have or not? Have, right?
Yeah.
That one can, but can use or not?
I haven't gone out to check yet.
Yeah, because for my place,
left the house.
because I know that almost all condos they already ban it. Almost all condos ban it already.
But you can't even work out alone, man.
Cannot.
If you're doing it alone,
you cannot do it in public. Like if you live in landed, I mean no one really cares lah. But for condominium, there's still a community.
Yeah.
So that's why they have to ban it, because it's still common facilities. But if like you want to do push-ups in the middle of the road, nobody is going to stop you lah. That one can as long as you don't see the red tape, you know.
Yeah.
Yeah.
Oh, at first I thought you were talking about the Zoom thing, about how they like schools will ban Zoom and everything.
Oh no lah, that one I don't really care.
Yeah.
But I'm just saying that, like, because there was this one time I just like a few days back I wanted to go and do pull-ups. I was like, screw it. But
then your one was closed.
I went to the fitness, the public fitness corner.
Yeah, the one they close.
Yeah, I thought like, never mind, you know, just go in and do like 10 pull-ups. But actually better not. Now they don't give you warning already. Upfront they straight away give you $300 fine.
Yeah, now it's just a fine.
Yeah. Okay, shall we proceed?
Yeah.
Okay, so I hope I clarified your doubts for convergence and divergence. Divergence is not an issue, okay, because divergence we will learn later. Okay. So over here is, as you can see here, finding un from Sn. Okay, finding un from Sn. Okay, well, what does this really mean? Okay, let's take a look here. Okay, we need to know what is Sn first. Sn means what? It's the sum of the first n terms. Okay?
Yeah.
Okay, Sn means the sum of the first n terms. So sum of first n terms means what? Means it's like u1 starting from the first term, right? Plus u2 plus u3 all the way to plus un minus 1 plus un. This is Sn.
Oh.
Okay?
Yeah.
Yeah. So over here, right? Actually, how your school shouldn't have taught this first, because in this case you'll be a bit confused, like, why and how do I apply it?
Yeah.
Okay.
Yeah.
Yeah. Okay, so basically in the question, right? Now I teach you how to apply it. Okay, so sometimes in a question, right, they will tell you, okay, the Sn given that Sn is equals to 2n minus 3. Okay, means the sum of the first n terms is equals to 2n minus 3. Means you want to find the sum of the second term, which is S2. This is sum of the first two terms. Okay, sum of first two terms will be 2 times 2 minus 3, which is 1. Okay?
Yeah.
This is what it actually means, but okay, I haven't finished the question. So over here, given that Sn equals to 2n minus 1, they will say find un. So how to find un? Okay, they give us formula for Sn. We have to find un. Un is what? What is un? Un is the nth.
Is a term.
Yes, it's the nth term. Correct. So how do we find that? Okay, take a look here. Let's say if it's S5, for instance. S5 means what? S5 means U1 plus U2 plus U3 plus U4 plus U5. Agree?
Yep.
Agree, yeah? Okay. So when the question say they want to find UN, so in this case, if it's S5, means I want to find U5. Right?
Yeah.
Okay, we just do a comparison just to verify the answer. You see, this is Sn, this is Un. Okay, so now in context to the question, now the question says S5 means I want to find U5.
Yeah.
Agree? Yeah. So
Yeah.
how do we find U5? Considering that we can only find the sum of it, the sum of the first 5 terms. How do we find the 5th term, which is also the last term?
Use the formula.
Use the formula.
2n
Okay,
minus
but
3.
why? Okay, the thing is how you see, because if you just substitute n with 5, you're going to get 2 times 5 minus 3, which will get us 7. But this is, what does this n, what does this 7 represent? It's the sum of the first 5 terms. It is not equals to the 5th term.
Just take it like sub in 4 then minus.
Sorry again?
Sub n equals 4 then minus.
Very good. That's exactly what we should be doing, because over here, if you look,
That's why they put Sn minus 1.
yes, correct. Because that I'm just trying to explain to you how this formula came about. Okay, so from here we can see S4 is equals to U1 plus U2 plus U3 plus U4. Agree?
Yeah.
Yeah. So with that said, we can cancel, 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 cancel. So using U5 minus U4, we will get our U5. S5 minus S4 will get our U5. Agree?
Yeah.
Yeah. So that's why the general formula is as such. Sn minus Sn minus 1 is equals to Un.
Yeah.
Can
Oh.
So, but the thing is, I was just trying to explain to you how is it being applied, because when they just explain to you in contextual form, right, it's very difficult for you guys to accept it. But in A-level question, this is what they will do to you. They will give you Sn, they want you to find a Un.
Oh.
Understandable?
Yep.
Nice.
I understand now.
No, you must say I am understandable.
I am understandable.
Nice.
I'm
This is when you play the laughter.
Okay, I'll play when you make like a very corny joke.
Okay, sure.
Yeah.
Okay.
Yeah, I got you ready.
Can I move on?
Mm-hmm.
So far this page, I hope I clarified everything.
Wait, then what about diversion?
Later.
Okay.
Yeah, we are moving to it. Okay. Not this. Okay, maybe I'll just go through. Yeah, I will just do it my way first. I'm going to teach you about this thing called APGP, because this is when you will learn about conversion and diversion. Okay.
Okay.
So now I'm going to do this thing called APGP. Okay. What does APGP means? APGP it comprises of AP and GP. Okay, this is what you will keep hearing or teachers say, you keep hearing your friends say, or even is on the notes itself. Okay, they will bracket APGP. So what is AP? AP means arithmetic progression. Arithmetic progression. Or it's a sequence. Okay. GP means geometric progression or sequence. Okay, there's a difference between the two, of course. If not, they won't be given different names. So, but in this chapter, you also know it as sequence and series, right?
Yeah.
What's the difference, man? What is a sequence and what is a series? Do you know?
Not really.
Okay, so this is why when you have to understand. There are some students up to A levels itself, they still don't know what's the difference between a sequence and a series. But nonetheless, they can still get the A lah. So, but
Really?
it's still
Oh,
it's still important what sequence and series means. Sequence means 1, 2, 3, 4, 5, so on and so forth. Okay, this is a sequence, right? This is a number sequence, right?
Yep.
A number series will be what's the difference?
It was a sum.
Very good. It's the sum of a
Oh.
can.
Yeah.
Yeah, that's about it. Okay, can I move on?
Yeah.
You can write this down somewhere.
I wrote it already.
Okay. So I'm going to start with, so there are two things that we are going to achieve today, which is AP and GP. We're going to understand what constitutes an AP and how to go about finding the terms and the sum in an AP, and also the terms and the sum of a geometric progression. Okay?
Yeah.
Yeah. Damn, I haven't had my lunch. Damn hungry, man. Okay, so what is AP?
You can eat now, right?
You can eat now lah.
Oh,
How I eat now?
one hand draw, one hand eat.
Oh, then how am I going to speak? I eat through my mouth and I don't eat through my ear.
Wait. Wait.
Okay, thank you.
You can hear it? Oh,
Yeah, I can. But it's not very loud.
yeah.
Yeah.
My mic didn't display anything.
Oh. Okay, what is an AP? Okay, I'll show you an example of an AP instead of telling you what is an AP. I'll show you. This is an AP. This is an AP. This is a GP. What's the difference?
Oh, the GP doesn't have like a standard increase. I said +2, then +4, then +8.
Okay. Look more carefully.
Oh, it's multiplied by 2. GP is a multiplication by 2.
Correct. So to simply put, AP, we have a common difference. GP, we have a common ratio, denoted by R, denoted by D. All good?
Yep.
Yeah. So let's say right now, you see for this geometric progression, for this arithmetic progression, 2, 4, 6, 8, 10, 12, right? Okay.
Yeah.
This is the first term. This is the second term, sixth term, second term, third term, fourth term, fifth term, sixth term, right?
Yeah.
Right. Right now, if I want you to find the seventh term. Can you tell me what the seventh term is? Which is U7, right? What's the seventh term?
14.
14. Wonderful. Correct. Anyone who is not blind will be able to answer me. Okay.
Not fast enough.
So, what if now I want you to find me U28?
Oh, let's use the formula. I think you went through this with me in O-levels.
Yes, correct. Which is the number pattern.
Yeah.
Yes, I did. Because I wanted you to use it in O-levels. Because
yeah.
some
Shortcut.
teachers did not teach. Yeah.
Mm.
It's a shortcut. I did went through this with you, but that's why I told you that at A levels, and even if you go the IB track, same thing. You will still need to learn this. Okay. So how do we find U28? So this is where we have to use the formula. Okay. So things have been made very, very convenient for you guys, which not sure why they made life a living hell for secondary school kids when finding number patterns.
Oh yeah.
Yeah, they should have taught them the formula and everything will be easier. Because anyways, when they proceed to JC, they still learn it. They proceed to IB, they still learn it. So,
Yeah.
yeah, I have no idea why. So, okay, but never mind. I'm just going to tell you this formula. It should be in your formula booklet, but it's not in your formula booklet, but it is in your notes. But I need these formulas to be at the back of your head. Okay, every single lesson starting from this lesson onwards, before you even start the lesson, you'll be writing out the formulas without referencing. I mean, it means I need you to memorize it. Okay. Yeah. So UN, which is the n term, okay, it will be equals to A plus n minus 1 D. Okay, what is A? A is the first term. What is D? I mean, I think needless to say what is D, right? You know what is D, right?
D is
called the what?
Oh, is it the increase? The common difference? Yeah, common difference.
Yeah, D is the common difference, right? So let's say if I want to find U7, okay, as you can see, U7, what's the first term? 2, right?
Yeah.
Plus 7 minus 1. What's the common difference here? Is 2. So we get 2 plus 6 times 2 is 12.
Yeah.
6 times 2 is 8.
Yeah.
You should start to play the laughter. You should play the laughter, man.
Wait.
6, it's okay, it's okay.
Yeah,
don't worry. Our viewers are already laughing. So 2 plus 12, it will give you 14. Isn't it what was predicted by you just now?
Yeah.
Magic. Hey, that's a good one. That is a good one. Not bad, right?
Yeah.
See, actually, I'm not a math teacher.
You're a magician.
I'm a magician in disguise. Yeah. Okay. So we already know the formula for UN, but what if I want to find the sum? Okay, like let's say for 2, 4, 6, 8, 10, 12, I want to find the sum of the first 3 terms. Can you tell me what it is?
Sum of the first 3 terms.
Yeah, sum of the first 3 terms. Can you find me the sum of the first 3 terms?
Just do the same thing, but add everything together.
Okay.
So like you sum A like 2 plus.
No lah, dude. You don't need to do that.
Oh, so
you can just use 2 plus 4 plus 6 what? Play the laughter. Yes.
It's very loud.
Yeah. It's 2 plus 4 plus 6, right?
Yeah.
Yeah. So I don't know how you want to do the longer way.
No, I thought you want to find like outside of that, like the other end terms.
It's okay. Thanks for bringing happiness and joy and laughter into my life. Every Sunday, 1 to 3 with Kenny and Greg.
On Comedy Central.
Yes, Comedy Central.
Oh my god, yeah.
Okay. So, you must remember to share the video with your friends. Serious? I need more viewers.
Okay.
Yeah, share the inequalities one. I think that one quite helpful also. The graph transformation also. Serious.
Okay.
Just send a group chat or something. Just say that, hey, you know, there's this like, I heard that there's this. You don't tell them that it's you in the video. You see if they can identify it's you.
Okay.
Yeah. Okay. So you can just tell them that, hey, actually that I realized that there's this math video in this channel that's quite helpful. Maybe you all can take a look.
No one's gonna do that.
You never know. I just need them to click on it. And after that, they're like, this fella sounds like Greg,
But your video is like 2 hours long.
No, they won't watch the full thing. Usually people only watch the first few minutes.
Yeah.
But I just need them to watch the first few minutes.
Okay.
Yeah. Okay. So how to find the sum of the first three terms, which is S3? Is 2 plus 4 plus 6, right?
Yeah.
Gives me 12, right? Agree?
Yeah.
Yeah. I mean, you can use your calculator to find it. If you want to find the sum of the first 5 terms, is it achievable?
Yeah.
Yes, it
It's
is.
30.
It is. Yeah, it is. But what if I want to find the sum of the first 35 terms?
You gotta use formula.
Yes. Yes. You are definitely not left.
Pretty fun.
Okay, so now I'm going to introduce you the formula. The formula is this. Okay, so what's Sn again? Sn is the sum of
That's how the
first,
n terms.
yes. Always remember that. So it's equals to n, oh my god. What's going on? N over 2 u1 plus un. What is u1? U1 is U1 is what?
Wait, it's just 2.
Yeah, it's just the first term.
Yeah.
U1 means first term. What is un?
There's the like 1.
What is un?
Is it 1? Or
No,
like the n term?
it's the n term, which is also the last term. So it basically will be n over 2, first term plus last term. How to find the last term? How to find the n term?
Oh.
So in other words, you want to simplify this, it can become n over 2 a plus n minus 1d, which gives you 2a plus n minus 1d. This is probably the equation you will see in your notes.
Yeah.
But usually how I memorize it, I will either memorize it this way or this way. Just these two is fine. Clear?
Yeah, I'll try to find it.
No problem.
Wow, it's so far behind. They made it. Yeah.
On it?
Yeah.
Okay. So now we know how to find the sum of a divergent arithmetic progression, which is this, the Sn. So Sn basically means the sum of a divergent arithmetic progression, because we are going 2 plus 4 plus 6 plus 8 plus 10 plus 12. It goes all the way to, let's say, for instance, if I put comma 72, there's an n to it, right? We're just going to add from 2 all the way to 72. We're going to add this number of terms. So this is, the number will just get bigger, right? So that this means this sequence is divergent. Can?
Yeah.
Yeah. But this conversion divergent thing is not very divergent, not very important. It's conversion that is important. I can tell you upfront. What they test you is test you on the conversion. They'll ask you state why this is conversion. They won't say state why this is divergent.
Oh.
Yeah. Can. But the thing
Yeah.
is conversion. Conversion usually happens where? Happens in GP. Conversion don't happen in AP. Okay? Because AP is either it becomes super positive or it becomes super negative. Make sense? Because it could have been like 12, 10, 8, 6, 4, 2, 0, -2, -4, -2 and -2. Keep minusing 2, right?
Yeah.
Yeah. So the common difference here is -2. Common difference doesn't need to be positive. I must emphasize on that. Can?
Yeah.
Yeah. So don't worry about the divergent part because we should always be focusing on the conversion part. Because that's tested in the exam. Can?
Yeah.
Okay. Okay, so after which from here I'm going to move on to GP already. You need a break?
Okay, wait, can I go to toilet first?
Okay, now we take 5. I want to go and get something to munch.
Okay. Hello?
Yo, are you there?
Yeah, hello.
Sorry, man. Wow,
It's
just
okay.
now. Wow, suddenly my stomach and pain. That's why. Okay, let's carry on. Okay, now GP.
Yep.
So same thing. For GP, you still want to find an n term, right? So this is we have the first term, second term, third, fourth, fifth. What's the sixth term then? What do you think is the sixth term?
Like 32 times 2.
Which is
64.
64, exactly. So as long as you're not blind, you can do simple math,
Yeah.
you can get it. Right?
Yep.
But let's say if I want to find U12, how? Okay, so you have to use the formula again, right? So there's a formula dedicated to this as well. So it's actually UN is equals to A R N minus 1. What is A?
The first term.
First term. What is R?
The common difference.
Common. No.
Or like
D is common difference, dude.
Oh no, sorry. Yeah, the common ratio. Sorry, yeah.
Common ratio, yes.
Yeah.
Yes. So let's check if this formula really works. So let's say I want to find the sixth term, right? So it will be 6. So it will be 2, which is the first term. Our R is 2, right? And then our N is 6 minus 1. So which is equivalent to 2 times 2 to the power of 5, which is equal to 2 to the power of 6. And what is 2 to the power of 6? If you use the calculator, you know. It is 64.
Yeah.
Which is what you predicted earlier, right? Okay, so that's for UN. Okay, that's to find a term, the n term. Okay, what about to find the Sn then? You want to find the sum of the first n term. What's the formula to do that? Okay, so the formula is as such: is A 1 minus r to the power of n over 1 minus r. Okay. Hello.
Yeah.
Yeah. So it's A, I repeat, it's A bracket 1 minus r to the power of n minus over 1 minus r. Okay. Your school will give you something like that. Your school will give you another formula also, which is Rn minus 1 over r minus 1. Okay. Is there really a difference? There isn't really a difference. It's just taking out the negative and then transforming back to this. It's the same thing. Can you see it? If you were to manipulate, you take out negative, right? You still get the same thing. Yeah. They will say that, oh, this one is for where mod r is lesser than 1. This one is for mod r greater than 1, something like that. But in actual fact, we don't need that. We don't need this whole thing. It means the same thing. Trust me, just memorize one can already, which is this one.
Yeah.
Okay, just memorize this one can already. So we can find the sum from here. Okay, but be very careful. The n is always at the top. Can you see this power? Okay, the power is always the one at the top because a lot of people, they always get confused. So what are some of the mistakes that A-level students did? Common mistakes is that they sometimes write this. There are different ways of there are really different permutations of their mistakes. Some during A-levels they memorize as this. Some memorize as sorry. I've seen different answers like that. And I also have seen something like that also. Suddenly got different formulas popping up. Okay, so let's not repeat these mistakes that your seniors did. Okay. So the question is, when do we use Sn? When we want to find the sum of the first n terms, right?
Yeah.
Yeah. Sum of first n terms means what? We want to find the sum of the first n terms means that it is a finite sequence. Okay. What does it mean to be finite? It means that there is
Limited.
a last term.
Oh, yeah.
Right? So what happens when it is infinite? Okay. For infinite sequence, we do not use Sn. Okay. For infinite sequence, we use S infinity, which is what we learned just now, right? Is A over 1 minus R. Okay?
Yeah.
Yeah. So for infinite sequence, we will use A over 1 minus R. But the thing is, how we can see that people are like, Kenny, these two formulas look very similar. How do they correlate with each other? Okay, think about it. Let's say, for instance, okay, for infinite sequence, right, there are a few requirements for me to even use the infinite sequence. Firstly, of course, it has got to be a GP. Okay, of course, it has got to be a GP. Secondly, it must be infinite. Might as well don't say, right?
Yeah.
Thirdly, the mod R must be lesser than 1. Okay, what do I mean by mod R must be lesser than 1? It means R, the common ratio, must be between -1 and 1. Very, 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 very important. The mod R must be between 1 and -1, 100%, in order to use this infinite sequence. Sum to infinity. Okay? Okay. So just now the question was, how do I get from here to here? Okay, think about it. Let's say now we have a sequence that is like 2, 1, half, so on and so forth. Okay, something like that. Times divide by 2, divide by 2, divide by 2. Okay, so we already show that our common ratio R is half, right?
Yeah.
And it's between -1 and 1. And then as we can see, there is no end to it. You know, I can keep dotting up all the way outside my laptop. It will still keep dotting.
Yeah.
Right. Then over here, we can see that A 1 minus half to the power of n over 1 minus half. Agree?
Wait, this one is the infinite one.
No, this is the finite one. Now I'm showing you how we get from the finite formula to the infinite formula.
Oh.
Yeah.
Okay.
So now we are substituting into the finite formula. So our common ratio now is half, right?
Yeah.
Yeah. So you can see for infinite, right? What will this n be? What will this n here be? Can you see where I'm pointing to?
Yeah.
What will this n here be? For infinite, it will be a huge ass number, right? Like,
Yeah.
I don't know, like 9 zillion, you know, that kind of number. Like huge number, okay? But
So infinity, yeah, basically.
yeah, to infinity lah. So let's be realistic. So do you have a calculator right now?
Yeah.
Okay. So can you help me calculate? 1 over 2, which is 0.5. You just put it to the power of 999 will do. 0.5 to the power of 999.
Oh, it's just 0.
It's 0, right?
Yeah.
It's 0, right? So look here. So if it's 0, so we get what? A bracket.
Oh, so if it's very big, it'll just be 0.
Yeah. That's why when the modulus R is between when R is between -1 and 1, okay.
Oh,
yeah.
yeah.
If it's more than 1, right? If it's more than 1, it will be the whole concept of compounding really. If you can compound like more than 1% of your account a day, in no time you will become a millionaire. Yeah. Really. You can compound more than, like, let's say you can compound just 2% of your account a day, right? You can go and calculate. You'll become a millionaire in no time. You can go and find the UN. Serious.
Wait, compound everything by 2.
Okay, but anyway, we come back to that later. Let's focus on this first. After this, then we go to that. Then we go to the millionaire question. Okay, so over here you calculated for me, right? 0.5 to the power 999 is 0, right?
Yeah.
So you get a times 1 minus 0 over 1 minus half, which is equals to a over 1 minus half, right?
Yeah.
Yeah.
Just do it.
Isn't it the same?
Yeah.
Yeah. So I'm just trying to show you from Sn, how did it get to the infinity, the sum to infinity formula?
So you just make n very big, then
N no, it's not make n very big. N, if it's an infinite sequence, n has to be big. N has to big really. Sorry, n has to be very big really. So actually, when we are using the sum to infinity formula here, right, we are actually using the Sn formula. We are actually using the Sn formula. It's just that it translates to this. You get it? Because when R is between -1 and 1, it becomes the sum to infinity formula. Okay? Understand?
Yeah.
Okay. So with that said, I have covered, or rather we have covered AP and GP.
Oh.
Right? Hello?
Yeah.
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 So my job now over here is done. We are going to go to questions. We're going to do some questions.
So this is the whole topic really.
This is for AP and GP. Not the whole topic of sequence and series. There are more to it, but for APGP, this is all you have. But because there's a next part called summation. Okay, what is summation? Summation is this symbol.
Oh.
Okay, but we are not going to learn today because if not, there will be too much information for you to take in. Okay.
Oh.
Yeah.
So you're doing the tutorial questions now?
No. Hold on. We're going to go to the questions that you sent me just now.
Oh. Oh no, actually, I can't. Actually, wait, never mind. I don't know yet.
So do I need to go through that?
Only the last part. Like how come it's convergent? Like part 5.
Okay. So why is it convergent?
Like the working is on the solution already, so no need to do everything.
Oh, okay. Wait.
It's so small.
Nanotech.
I only don't understand like the last part. Like SN, whatever.
Which part?
Like the last line only, the explanation.
Oh, the last line. Okay. So
Yeah.
so this one you get it, right?
Yeah.
So when n tends towards infinity, means when n becomes a very, very big number, okay,
Yeah.
Yeah, because when we want to determine whether something is convergent or not, we need to let n go towards infinity. We need to let n become very big. So we know that, it's like a light ray. It's like a torchlight or or basically a light ray. How do we know if the light ray converges or diverges? We have to really like let the light ray move, right? Then we can look far to see, hey, does it converge to a point like a laser pointer, or does it like diverge like a torchlight? Correct?
Yeah.
Yeah, that's why we need to let n go to infinity, which means we need to let n take on a very, very big number. Okay. So they say as n tends towards infinity, 2/3 to the power of n will go to 0. This one is what we tabulated just now. When r is between 1 and -1, remember just now?
Yeah.
And then if n is big, it will be approximated to 0. Make sense?
Yeah.
Yeah. So if we know that this part over here, this 2/3n is going to be 0, then what will we get from Sn? So Sn will be equals to 6 minus 6 times 0. Correct?
Yeah.
Yeah. Then what is 6 minus 6 times 0?
6.
6, exactly.
Oh, so wait. So you have to state that as n tends towards infinity, then
No,
you like
no. Sn doesn't tend towards infinity.
no, it's like as n tends to infinity. You write there as n and tends towards infinity, then
Oh yeah, Sn, yes, you have to state that.
yeah, then you decide whether it's going to be like convergent or
Yes,
divergent.
yes, yes.
Oh, okay.
So so I repeat, as n tend towards infinity, there will be a certain value that is going to become 0, 100%. It's always like that. When
Yeah,
n tends
yeah.
towards infinity, there will be some value that will become 0. So we know it's 2/3 the power of n becomes 0. So when 2/3 the power of n becomes 0, Sn will become 6, which is a finite value. And therefore series is convergent because it will tend towards it.
Oh, wait, but so if like the 2 to the power 3 n like it's not equals to 0, then
Then divergent.
but then
Oh, actually it doesn't matter. Doesn't matter. As long as it tends towards a finite value, we can read it. But
as
usually
long
it
as
becomes
Sn
0.
tends to a
Yeah,
finite value.
correct, correct.
So it can be like 6 minus 7 or something.
But actually, no matter what, it should become 0 one. It has to become 0
Yeah,
because
yeah.
you see, if let's say right, instead of 2/3n, it's 3/2n.
It'll still be 0.
No, it will not be.
Right?
It's 1.5 to the power n. You try you use a calculator,
Oh,
1.5 to the power of 999.
oh, it's math error.
Yeah, it's going to be a super, super huge number. Because this n it keeps increasing, it keeps increasing towards infinity.
Oh,
100%, right, it has to tend towards 0. If it doesn't tend towards 0, right, it means it's divergent already. You understand or not?
but it only works for like fraction.
Yes,
Like
you're right. When r is between -1 and 1, so 100% must
oh
be
yeah,
fraction.
yeah. Okay, that thing.
Can
Yeah.
I hope you feel better about this thing now.
Yeah.
Okay. Oh, we went through this already.
Yeah.
Okay, right now, more importantly, this conversion and diversion one is not super important now. What's more important is the APGP part. So maybe I would like to go through with you some of the APGP questions. Do you have the APGP tutorial?
Yeah.
Yeah, can you just take the first page for me? Just the first page.
Okay. Actually, can I go toilet for a while? I sent it already.
Can.
Okay, hello.
Yes, and we're back. Never mind. Screw this. Okay, great. Let's try this. Shall we?
Yeah.
Okay, I'll go through this with you. Okay, they say that an arithmetic series. Okay, so what do we know about an arithmetic series before we even start anything? So an arithmetic series has what? What's the UN? Remember or not?
Is it the formula?
Yeah, what's the formula? Remember the formula? Do you write down?
Oh, the A plus N, is it the one?
Yeah,
A, oh, N minus 1 D.
yeah. Then what's the SN?
Wait, I forgot. Wait. This one is. Oh. Is it the A1 minus RN thing?
No, that one is for GP. Now they're talking about AP. They said arithmetic, right? Arithmetic.
Oh. Oh, UN minus 1.
Huh?
Is that one?
No.
Yeah, I read this.
Do you write down or not just now?
Yeah. Oh. Yeah, n over 2 un plus un. u1 plus un.
Alternatively, it can also be n over 2, 2a plus n minus 1d. Okay?
Yeah.
Okay, so an arithmetic series have first term 1000. So from here, we can tell that, okay, A is 1000. Common difference minus 1.4. So it means that D is equals to minus 1.4. Okay, calculate the value of the first negative term of the series and the sum of all positive terms. Wow. Okay, so there are two things we need to find. This one thing is the first thing, this second thing. So we need to find the first negative term of the series. How do we find that?
Oh, also let wait, let the a plus n minus 1d equals to like negative, like a negative 1.
What again?
Let un equals to negative 1.
Un, why equals to negative 1?
Or can it be like just any negative number?
How? How do you use
So,
math to express that? How do you use math to tell people
so
that,
like,
hey, I want un to be negative?
less than 0.
Ah, you see, when you talk to yourself, everything will flow, right?
Yeah.
You want un to be lesser than 0, you're right. So we just need to solve for this one. Can you solve it for me?
Yeah. Yeah, I got it.
Okay.
Mm.
So
Do
let
I
me go through.
send do I send to you or what?
It's fine. So I'll just go through here, then you can tally with it. Okay. So we know that un is equals to a plus n minus 1. And we know a is 1000, d is minus 1.4. So we have 1000 plus n minus 1, d is minus 1.4, lesser than 0. So from here we have 1000 minus 1.4n plus 1.4 lesser than 0. So from here, after you solve, you get what? N is greater than
Uh,
which answer?
715.2857.
715.
0.2857.
Okay, so obviously we know that n has to be greater than what? What's the smallest value of n?
Has to be 716.
Yeah, correct. So when n is equal to 716, that will be the first negative term, right?
Yeah, you just sub it into the
Correct.
equation.
Then you just have to find U716. Very good. Okay. Next.
Yeah.
How do we find the sum of all positive? So this is for part 1. So now for part 2, we want to find the sum of all positive terms. How are you going to do that?
Use the SN equation. Sum of all positive. Oh. But actually, yeah, just take n as 715, unless you want to do everything again. Take n as 715.
Take n as 715. Okay. Yeah. Then?
So just sub into the n over 2.
Yes,
U1
correct. Correct. Okay, so we are done for this question. Let's move on to the second question. Simple, right?
Yeah. I don't know yet. I don't say too early. I get everything wrong again.
Don't worry lah. So at most, like, people will just comment.
What a dumbass. Wait, has anybody commented on your video?
Not yet. That's why I say I need help in publicizing it. Like, oh, just get the word out. Serious, man. Need some serious help here.
We have 53 subscribers already. Oh, nice.
Yeah. I need more. I need to hit 1,000.
Let's see the most popular. Shit, most popular is my one.
Yeah. You should help me to share.
Wait, you turn off the comments. Oh. You turn off the comments.
Oh, really? Yeah.
Yeah.
Okay, I should go and turn it on. Maybe after this.
Yeah.
Okay, come. Ready?
Yeah.
It's given that A, B, and C are first three terms of a geometric progression. That's the first line, right?
Yeah.
Okay, they say that A, B, and C, they are the first three terms. Geometric progression means A, comma, B, comma, C. So what does this mean? What's the relationship between A, B, and C? What's the relationship?
First three terms.
Yeah, okay, they are the first three terms, yes. But what would be the relationship? How do I get from A to B and B to C? Since they are geometric progression. What does it mean to be part of a geometric progression? They have a common
Difference.
No, geometric, brother.
Oh. Wait. Oh, wait. Oh, common, like,
What's that word? Common what?
common ratio. Is it?
Common ratio. Yes, that's the word. Okay. So from A to B, we need to times R. From B to C, we need to times R. Oh my God, it looks like a person's face.
Yeah.
So from A to B times R, from B to C, we times R, right? That's what it means.
Yeah.
That's what it means. Common ratio. Yeah. So it's also given that A, okay, now it's another one. A, C, and B, they are the first three terms of an arithmetic progression. What does that mean?
So yeah, you got common difference.
Huh? Common difference, yes. So from A to C, we have to plus D. From C to B, we have to plus D as well. Right? Okay, so now we need to look at part one. Part one says, to show b square is equals to AC. You want to try? I mean, you cannot say no lah.
Yeah, I'm not sure how to do the first one, right?
It's fine. It's fine. Shall we?
Yeah.
And we shall. Let's go. Okay. So we know of these relationships, okay? Like this, can you see back? Oh yeah, you can't see. Okay, can you see where my mouse is pointing to?
Yeah.
Yeah, we know of this relationship and this relationship. Okay. So firstly, we will know that, okay, A times R, or rather AR, sorry, B over A is equals to R, right?
Yeah.
And we know that C over B is equals to R, right?
Yeah.
Make sense?
Yeah.
So in other words, B over A is equals to
C
over
B.
Do you think you can carry on from here?
Oh my god. Oh.
Oh your god.
I.
Oh your god. Nice. Oh your god. So from here, crisscross, we will get our B square equals to AC. Sean.
I was using the other one. Using the D.
After that, you also have to use the D. You have to use the D for the next part.
Yeah, for next.
Yeah, you want to
I was
try?
using D for the first one. Yeah, actually.
Yeah. Your school is not yet here, right?
No.
Okay, very good. We are ahead.
Yeah.
No, actually, we are 2 heads.
Actually, not really, dude. By the end of the week, they probably be like doing the next part.
It's okay, but right now you understand a lot better, right?
Yeah.
Mm.
Okay, yeah, I got it. I got
Oh,
the
yeah.
answer.
Nice.
Yeah.
Nice.
But a
Okay.
bit too long though.
A bit too long. Let's see. So we know that.
Because like, I took too long to do.
Oh,
But
okay, okay.
I got it, yeah.
Okay, can. So part 2. Hence show that it's a hence question, right?
Yeah.
So which means that we need to use this and this. So what is the term that we need to substitute?
What's the... Oh. Like using the B square equals AC and the
Yeah.
C equals, yeah.
Can you do that?
Yeah, sure. Oh, this is just normal simultaneous, right?
What do you mean?
Just sub the C into the
Yes,
square.
correct. Very simple, right?
Okay, then we just go next.
Yeah. So once you sub it in, you will get this. Okay. Given that the sum to infinity of the geometric progression is S, find S in terms of A. How?
Must use the formula, right?
Find S in terms of A.
Wait, can we just use the formula like Sn equals to the A1
S
minus R?
infinity, not Sn.
Oh, S infinity.
S infinity is equals to
A1 minus R and
A over,
1 minus R.
yes.
Oh, wait, but I thought it's GP, right?
Yeah, it's GP.
Yes. Oh. I'm sorry, I didn't see the sum to infinity. I was using the sum, yeah.
Hmm.
How do you do part 3?
Good question. How to do part 3? Okay, so part 3, right, you will write to, your starting point was correct, that we have to use this, okay? A over 1 minus R. Okay, so A is the first term, right? Make sense? Which is this.
Yeah.
Correct? A is the first term. So, but the thing is, we want it in terms of A. So we are going to leave the numerator as A because that's the first term, and A means first term, and in this case, this unknown A is also the first term.
Yeah.
You understand? So we are not supposed to find A. We are supposed to leave A in terms of A. But what we really need to find is R.
Yeah, I like sub B over A as R, then AC square over A.
Correct.
But then I don't know.
But the thing is, you sub it at the wrong place. There's a reason the setter's intention though. Why did they ask you to do part 1? Because you need it for part 2.
Yeah.
Why did they ask you to do part 2? Because you need it for part 3. This is how the person created the question, the setter's intention. So you have 2b over a square minus b over a minus 1 is equals to 0. Don't you find it weird that they suddenly just ask you to find this, then after you just stop there? Doesn't make sense, right? Because over here we know that b over a is r. So what we're supposed to do is we're supposed to replace b over a with r. Then from here we can solve for r.
Oh.
Yes.
One or minus half. But it has to be between 1 and minus 1, so it reject the 1, is it?
1 or minus half, it has to be between minus 1 and 1. Yeah.
Yeah, so to reject, yeah.
Yeah. Then you have your R.
Oh my Christ.
Got it? So you see, what will differentiate you from everybody is not about memorizing formulas or what. Of course, people who don't memorize formulas, out they go. You know, they are not even deserved to be competing in this league really. But what will differentiate yourself from people who only memorize formulas is to identify, to be very versatile, to be able to identify the setter's intention, how they create the question. When I look at the question, I'm looking at how this tutor, how this teacher create the question. Understand? There's a reason why they ask you to do part 1, why they ask you to do part 2, and why was this whole thing in part 3? Why was it in the last part? Understand or not?
Yeah.
Yeah. So once you are able to acquire this skill, it's not about memorizing. It's once you're able to acquire this skill of creation, okay, using your imagination to understand why what the person is thinking. How did this person create the question? I tell you, you'll be invincible. Just like me. No lah, I'm not lah. I'm not invincible. I'm just godlike.
Special power.
Special power. Can
Yeah.
Okay. Okay, dude. Unfortunately, we might have to continue the next lesson.
Oh. Oh man, okay.
Because I have another lesson actually.
Yeah.
But today I seriously like snowball like xiao.
Yeah.
So, or anytime you need a consult, you can just let me know.
Yeah, I'll just text you all the questions that I don't
Yeah,
know.
you can just text me, then we can Zoom or something.
Yeah.
Yeah, can?
Okay.
Okay, we
Please
have come
like,
to the
share,
end.
subscribe.
Yes, please like, share, and subscribe. To
turn on the post notifications.
Yes.
The little bell.
Yes. Thanks for tuning in to Math with Kenny every Sunday 1 to 3 p.m. with Kenny and Greg.
Play music at the end, outro song.
Okay, what kind of music?
You got a lot of songs on your playlist.
Okay, wait let me
No, like you edit. Like you end this thing.
Oh, you mean I add it in?
Yeah. Okay, then
Okay.
edit this part. Edit this part so that
Okay. But this is the part that makes it funny.
you can edit at the end if you wanna. Like after the outro song, just for fun. Like a purpose.
Okay. Okay. How about I send you the video and you do it for me?
I don't know how to do it.
I damn lazy to do it. I'll just leave it as it is. Why not you sing a song for us?
Okay, okay, fine.
Okay,
Just leave it as
come.
it is.
Greg will be singing a song for all of us.
Okay,
Okay, we'll just end here, okay?
Yeah.
Alright, goodbye.
Bye bye.